This video presents a series of anaglyph images taken by the Mars Reconnaissance Orbiter. Anaglyphs are stereo images designed to appear three-dimensional when viewed through anaglyph glasses. These glasses have a red and blue filter and are often associated with three-dimensional films. NASA creates these images as part of its effort to satisfy the mission's science objectives. These objectives include searching for signs of water, both past and present, to understand how it alters the planet's surface, and to map and characterize the geologic forces that shaped the Martian surface. Now is a good time to place a pair of anaglyph glasses over your eyes. If you wear prescription lenses, simply place the anaglyph glasses over your eyeglasses. This image, taken with the high-resolution Imaging Science Experiment camera, shows a location associated with the best-selling novel and Hollywood movie, The Martian. This area is in the Acidalia Planitia region. In the novel and the movie, it is the landing site of a crewed mission named Ares 3. For the story's central character, Acidalia Planitia is within driving distance from where NASA's Mars Pathfinder, with its Sojourner rover, landed in 1997. NASA's Curiosity rover used its navigation camera to record this stereo scene of a butte called Mount Remarkable and surrounding outcrops at a waypoint called the Kimberley, which is inside Gale Crater. The butte stands about 5 meters high. Its name comes from a mountain and national park in Australia. Curiosity's science team chose the Kimberley waypoint for science investigations because it contains several different rock outcrops in close proximity to each other. The long, sinuous, and raised ridges on this alluvial fan are inverted stream channels. The ridges may have been low-lying stream beds that hardened and then turned into ridges when surrounding material was eroded away. The fan is also marked by linear, streamlined ridges oriented roughly south to north. These are yardangs, streamlined remnants of material shaped by the action of wind-blown sediments that eroded away weaker material. This raised ridge is also an inverted stream channel. The formerly low-lying stream bed became elevated because the original depression filled with materials such as rocks and sediment precipitating from water that remained in place while adjacent finer material was blown away by the wind. On either side of the inverted channel are linear, streamlined ridges oriented roughly northwest to southeast. These are yardangs, which were also seen in the previous image. The material in the upper portion of this image is most likely hardened volcanic ash. It's being eroded into yardangs by strong, prevailing Martian winds. Aurum Chaos is a heavily eroded impact crater that contains jumbled blocks of material created by the removal of large quantities of water and ice. The light-toned sediments may have been formed in a lake that once existed in the crater. These collapsed pits formed when lava erupted from Arcea Mons, thereby draining underground magma reservoirs. The resulting voids collapsed, creating surface pits that are distinct from impact craters because the pits do not have raised rims. Athabasca Valles is a large channel carved by giant outbursts of groundwater somewhere between 2 and 30 million years ago. These streamlined islands were carved by massive floodwaters. The Cerberus Fossae are a group of troughs in the Cerberus region of Mars that run roughly parallel to one another. They formed due to crustal extension in the region. Some of the troughs, such as the one here, were at one time volcanic vents. Lava flow features can be seen emanating from this vent. The Colo Fossae region is a series of enclosed, intersecting canyons. The floors of the canyons contain complex ridges and grooves that are generally parallel to the canyon walls and look like they have undergone flow, called lineated valley fill. The ridges and grooves are composed of ice and boulders that were left behind when ice sublimated. This large outflow channel shows many characteristic signs that massive amounts of water once flowed through this area. Note the distinctive teardrop and streamlined islands. Lucis Planum is a part of the Medusa Fossae Formation, a broad, soft, and easily eroded region. Lucis Planum appears thin, rough, and covered with loose aggregate material. A stream channel is visible in the lower half of the image, clearly showing the erosive power of flowing water. Mars Vallis is one of the oldest valleys on Mars, formed and subsequently covered by layered rocks, which are now exposed due to erosion. Mars orbiters have observed clay minerals that form in water, both inside and surrounding this valley. Multiple impact craters within this image have been partially filled by wind-blown sand. Mars Vallis contains clay minerals that formed by the chemical alteration of rocks by water. The central part of this image is dominated by light-toned materials with curving fractures of many different sizes. These fractures do not have a preferred orientation, indicating that they probably formed by the drying of a thick mud deposit or the gradual rebound of the area as overlying material was eroded away. The impact crater on the left side has been partially filled in by wind-blown sand. This chain of collapsed pits, located on the southeast flank of Alba Paterna, a volcanic complex, formed when empty underground magma reservoirs collapsed. Similar to the pits on Arcea Mons, they are distinct from impact craters because the pits do not have raised rims. This image features an exhumed crater on Meridiani Planum, an equatorial region of Mars. The crater was buried after formation and then exposed by subsequent erosion. Remnants of the layered material that filled this crater can still be seen. This image shows layered sedimentary rocks and ripples that fill and surround an impact crater in Meridiani Planum. These layered deposits may have formed through the accumulation of sediment that was transported into the region by blowing wind and flowing water. Tantalus Fossae are a set of faults on the eastern flank of Alba Mons, one of the great Tharsis Montes volcanoes. Here, a fault cuts into the crater, indicating that the fault formed after the crater. Material has partially filled the depression and obscured any trace of the fault running across the crater floor. Shalbatana Vallis is a large channel with steep walls and a level floor that may have formed by water draining from nearby Ganges Chasma. Here, a section of the wall collapsed and produced a landslide onto the valley floor. This image shows a portion of the central mound in the impact crater Gale that is of interest to scientists because it's composed of light-toned, layered deposits. The layered deposits could have formed in a water-rich environment if a lake once filled the crater. Alternatively, particles suspended in the atmosphere, such as dust or volcanic ash, could have built up the layers over time. The paucity of impact craters indicate that either the deposits are very young or that they are being eroded away by wind. Wind erosion has modified this area, creating sharp corners and rounded depressions. This image is located within northern Sinus Meridiani, a region of ridged terrains and extensive stratigraphic layering. The crater's diameter is 10 kilometers and is surrounded by a prominent bench. The bench formed because surface material is eroding at a faster rate than the more resistant underlying material that comprises most of the crater.